Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Rowell and François.
Hello, everybody. Welcome to a brand new episode of the Clear to Send podcast. And we're here, I'm Rowell, and your co-host, François. How are you doing, François?
Hi, Rowell. Very good. Thank you.
Yeah, thanks for joining me today. We didn't have a new episode last week due to scheduling, but now we're here. We did recently a Cisco Champions Radio episode on RRM with Jim Florick. And so François and I are getting together just to recap this episode and talk about our experiences. But before we talk about that, I just want to tell everyone to, if you haven't already, go to iTunes and, leave a rating for our podcast if you could do so, and leave some feedback. And also, if you want to share any of these episodes that you found useful with your friends, go ahead and do so. You can also find us on Twitter at Clear to Send. That would be most appreciated. So let's talk about this RRM. We were on season 5, episode 10, and I couldn't believe that Cisco Champion Radio was on season 5 already. Could you believe that?
Yeah. No, not really. Yeah.
Yeah, so
that's pretty good.
Yeah, and they invited us to co-host an episode with Jim Florick, who is a seasoned veteran around RRM. And what François and I wanted to do is kind of provide our own experience that we've had when it's come to using RRM in our environments or in different environments, and kind of generate a discussion with you guys, the listeners, and knowing what you guys think about RRM. Do you think it's a useful tool that you're able to use? Do you find that you have to tune it quite a bit for your environment, or maybe it isn't working to your expectations? But that's what we're going to talk about today. Maybe, François, you can kick it off. When are you using RRM quite often in your environments?
Yeah, so the way I work, usually being a consultant, usually a customer calls me to deploy a new Wi-Fi network or fix a Wi-Fi network, and I'm kind of in and out, right? Mm-hmm. So it's sometimes I do, sometimes I don't. Depends on the customer I'm working with. Sometimes they want me to. Sometimes it's just my own decision. I do whatever is best for the situation given. But yeah, I've worked with it before. I've used it, tried to adjust it as much as I could. Obviously, it's RRM is a big piece, right? We talked about Jim. We talked about it with Jim, and mm-hmm. it's a set of all these different algorithms working together to adjust the radio environment, and it's not easy to get a grasp of, and knowing how to adjust it. Mm-hmm. So I feel like I'm still learning as I go, right? It's like you're always discovering those little things. But yeah, definitely try to, I've definitely used it before and use it, I still use it. So to answer your question, yes.
Okay.
I do.
Yeah. And I use it quite a bit. There are a lot of times where I switch between static versus dynamic radio management. And I probably side a lot towards the static side, because that's, for one, we always use Ekahau for our designs, right? And we're always using a static design. So static channels, static transmit power. And when we validate that design after the configuration, usually the configuration is supposed to match that design. So I've already tuned all the channels statically, have assigned them. And then you do your validation survey and you go, yep, it looks like what the design looks like, or maybe there's some tuning that needs to go on. And then usually I either set it that way and be done with it, because I know what to expect, right? Because with RRM, you don't know what's going to happen. You don't know what channel these APs are going to set themselves on, or you don't know what power level they're going to set themselves on. And so I like to I side more on what I know I should expect from my wireless environment. But when it comes to managing a lot of APs, and I'm talking hundreds and thousands of APs. So like in my environment where I have a campus environment, there's well over 4,000 APs. It's kind of hard to configure everything statically. It becomes inefficient to do it that way. And when you, I think the most challenging part for me is not really just the static configuration of all these APs. It's the validation part, which is, okay, if I'm going to validate this environment, what am I going to be validating it against, right? Because if I've already done the design and then you go and do a validation survey, it's not going to match exactly if you've already ran RRM in that environment. Am I correct?
Yeah. The validation and the design are very tricky, I found, with if you want to design or validate RRM, right? That you're gonna have more validation work to do for sure. Right, the situation you explain where you design everything in how the channel, the power, and then you implement this design. The validation is just, you walk around, you make sure that everything matches your configuration, and then you're pretty much done for the RF. Validations. You might do other validations with client devices, applications, and so on. But for the RF environment, you're pretty much done. If you want to design for RRM, first of all, you're going to have to wait for the RRM to settle down, right? For your infrastructure to settle down. So you have the final, the ultimate channels and transmit power decided by the algorithm. And then you're going to walk around and then do your validation. And then you don't know what to expect, right? Because you don't really know what RRM chose for you. So yeah, you're going to have to do a little bit more analysis afterwards to make sure that your design is good from an RF standpoint.
Yeah.
That's how I see it. If you want to do the job, thoroughly and make sure you
part of that is also validating RRM itself, right? If whether or not RRM is working for you, that's one way to see it is when you do your validation survey, you'll see all these APs on different channels, hopefully, because if you do see them on the same channels, I think this is where Jim Florick was talking about that. Like you said, you need to wait for that algorithm to settle. And also, if you have made a lot of changes in your environment, you need to trigger that algorithm to restart so it can reevaluate the whole environment. And that's part of waiting for it to settle. And that way, all your APs won't be on, say, channel 36, because that's when they start up, that's the first channel they pick.
And also, when you validate your network, right? If you design for RRM and you deployed everything with RRM, when you validate, I found that you always spend a little more time adjusting the RRM settings, so you can, get what you expect. And this can take a little while because you're gonna adjust some settings. You're gonna wait for it to settle. You're gonna see how it's gonna impact your APs, and then you're gonna take your decision for what the next move is. Do I adjust it more? Do I leave it as is? Or do I move to another setting to adjust? And this adjusting can take a little while because every environment is different, right?
Yeah, and I find that when RRM is turned on and the client is saying that Wi-Fi is not performing very well, it's usually due to, like, when we were talking to Jim about this, it was designing for RRM in mind. What does that mean? And to me, a lot of the issues stem from how APs are mounted or how antennas were, what direction they were in. And I think that's where a lot of RRM issues come into play, is because of how these APs are laid out on the floor plan. I've seen so many APs just lined up down the hallway, just 10 feet away from each other. And when RRM is turned on, each of the APs hear each other very loudly. And so the power gets tuned down so low that it creates coverage holes for the clients. And that's because the APs just weren't placed strategically, where the users were. Instead, they were placed in the hallway. There's not many users that sit out in the hallway. So that impacted the RRM algorithm quite a bit. And so I think that for me, when someone says design for RRM in mind, I automatically the first thing that pops to my head is where's the AP placed.
And also, it depends what we mean in terms of design, right? Are we talking only about designing for RF, or are we talking about designing for, a coverage capacity and taking everything into account to make sure you're achieving the goal, you're meeting your requirements, the business requirements. What I like to do nowadays is to take into consideration the coverage requirements and the capacity requirements, and then you can put it into Ekahau and see how it's going to play out in your design. If you assign your channels, if you choose which AP, obviously you choose which AP you want to use, and if you choose how you want to configure your AP, how many devices you have in your environment in specific areas, it can give you a good idea of how well your design will be able to handle the capacity of devices. If you don't know which channels those AP would have, it's harder to get it right? So if you're thinking of using RRM in your deployment, do you do all the capacity planning and all of that in Ekahau, or is it worthless and it's better to do it afterwards when you know which channels you're using? Do you know what I'm saying?
Yeah, should we let RRM kind of take advantage of that situation? But again, if you're using Ekahau, does that go back to your static design, or should we let RRM pick what channels and transmit power to use? I don't know. That's kind of that, I think, where the applications don't take that into consideration, right? Because they don't know the Cisco's algorithm for all of this. I mean, even though Cisco's documentation is publicly out there and they tell you how the algorithm works, I think trying to plug that into an application could be a recipe for disaster if the application doesn't get it right, doesn't get the algorithm right. Because there is a lot of math involved. We don't know what that math is. Yeah,
exactly. It's not as straightforward as what you would think, right?
Yeah. And also when it comes to using RRM, maybe you use this as well. Do you use RF profiles in your environments where I use a lot. I use RF profiles where I have high density areas. So I don't use the built-in ones. I'll create a copy of that and then modify it to what I think it should be for high density and capacity areas like auditoriums or for large events that are happening in a specific area. So going back to RF profiles, I tune the RF profiles for, say, high density environments where I will use a specific range for power, right? How low I'm going to override those transmit power settings, and also make a minimum data rate, for example, higher than I would for an office environment. And then also play that into AP groups. And I think the algorithm for RRM will take all of that into consideration. So that's why it's difficult, I think, to try to design for RRM within your design application like Ekahau, but maybe there is a way to do it. Yeah. I'm not sure if there is, but typically when I'm using Ekahau, it's usually for a static environment.
Yeah, I agree with you. Just means we have to spend more time going back to the validation, right? To me, validation, the validation part is a key part in the Wi-Fi, cycle, the Wi-Fi project cycle. Because it's not only about, to me, it's not only about validating the RF, it's also validating the user experience. And that's kind of like what the customer is paying for, right? So it's important as just more like a, customer relationship to do the validation. But going back to the RF profiles, I think they're great. It gives us a lot of flexibility. To tune our environments, just like you said, if you want to change your data rates, if you want to change your power levels, To talk about RF profiles, I talked about it with Jim, but I always take the warehouse example, because in a warehouse you always have like offices, and then you have the warehouse itself, and you're not necessarily going to have the same type of APs in both environments, and you're not necessarily going to have the same type of antenna and so on, devices requirements. So you're not going to your configurations might differ from one environment to another, and the RF profiles is a great way to give us that flexibility to adjust things. But like Jim said, if your APs are in different groups, they from a RRM standpoint, they're not necessarily going to talk to each other, right? So you need to understand that and take that into account when you do your design.
Yeah, there's just so much when it comes to RRM, because it's dynamic. There's a lot of moving pieces. The algorithms are in play. You need to keep your eye on it, for example, because we haven't spoken about yet even the interval, right? And typically I use a longer interval because I don't want the changes to occur when people are using it. But what Jim was saying is, if you've designed it well, right, you have a good design, your mounting of APs and antenna is ideal. They're the way they should be, and you do your validations and everything works. The changes shouldn't be happening that often. And that's true if it has been designed properly per requirements and with RRM in mind. RRM should not be changing a lot of channels and transmit power as it's trying to evaluate the whole environment. Because he was saying he would put things down that the interval down to 10 minutes, right? And that actually makes me nervous, but maybe it's because my environment is just not designed very well for that. And I haven't gone through the whole campus and redesigned everything the way I should, but that interval could be disruptive for users. And I would definitely hear about it, but maybe I should try using a shorter interval to kick off that algorithm, because it does take some time for it, like you said, to settle, to go through to consider all of those metrics from those APs.
Yeah, different iteration of the cycle. So if your cycle is like every 8 hours or every 12 hours, it might take a couple of days to, and then, God knows what happened in 2 days. You might have another change, right? So it's kind of like an ever-changing environment.
And it makes me want to test out a lot of these features with enough logging that goes on. And I'm trying to think about how all this information could be gathered, either by using something like Splunk or an Elk stack, to try to document all the changes that happen during the RRM algorithm and the metrics it's trying to collect. I think it'd be interesting to see if your environment is designed very well. How often are you seeing changes, and what triggers those changes, right? Is it because of the interference? Because you can set in RRM something like event-driven RRM, something that'll trigger RRM to kick in and make a change. And we didn't even talk about FRA yet, because that also plays into the algorithm as well.
Yeah, it makes it a little bit more complex.
Yeah, once FRA was added, I thought, man, RRM is going to be a little bit more difficult to really understand, because now you're saying, all right, if I have a radio, a 2.4 radio, and we've determined that it's now high density, somehow it's going to switch to a 5 gigahertz channel. And I don't know, it's just, how does that algorithm actually work, right? And how does the system know, okay, I need to switch to turn this radio into a 5 gigahertz radio, or don't use it, right? Don't use 2.4, turn it into, say, monitor mode. I don't know.
Monitor. I think it's very exciting for the future, because you know how they want to have this AI environment where pretty much the machine is controlling the network. I think we'll need tools like RRM to get this working on the RF side of things, right? And FRA is pretty much able to understand that you have a redundant radio, and you could use those radio for something else, monitor the environment or provide a second 5 gig radio to support more capacity on your 5 gig frequency band. And that could be tools that could be used by the AI machine to take decisions in the future if they want to. How I'm seeing it, they're probably going to interconnect everything with their DNS center, and then have this DNS center take the decisions, the automations decisions. I don't know if that's English, but automated decisions.
Yeah, no, that makes sense, because why not, right? As we're going into artificial intelligence, RRM should be helping with that process. It should be helping AI get you there. It should actually enhance the way RRM works, right? Because if it can tell now the environment's becoming high density, to me that sounds like AI. Like as it sees people moving across your campus and moving into a specific building, it should know, all right, I should be seeing hundreds more devices when usually the baseline is maybe 50 or so devices, right? So I need more capacity. So I can see that completely happening within DNA Center, and I'm pretty sure they're working on that.
And on one hand, it's very exciting, and all of that. The AI machine will be able to help us troubleshoot, or be proactive in the troubleshooting and all of that. But on the other hand, as a Wi-Fi engineer, you don't really want a machine to
take
set,
over.
To configure your APs.
But why not?
It's kind of like in Ekahau.
Why can't we do that, François?
I guess. I don't like. It's kind of like when you use Ekahau and you use the auto planner, and then the algorithm plays the AP for you. It's you get this weird feeling as, I think I like it better when I place the AP where I want.
Yeah, well, it's definitely not there.
It's like this controlling
feeling. It definitely
feeling.
Still needs a lot of work. It's not quite there yet, especially when the system has no idea about the floor plan other than walls, right? It knows there's a wall here, knows there's a wall there. It's gotten a little bit smarter where now you've created custom areas, and maybe with Ekahau working with Cisco, they can somehow tie that into the RRM algorithm somehow and through a hook or something. Yeah.
That would be awesome.
And then be able to help you design it with RRM in mind. Now, I want to talk about the naysayers of RRM. How do you have a conversation with people when they say RRM doesn't work?
It's a good question. Well, I don't know. I don't really know. It depends on how their environment is set up, right? Maybe RRM doesn't work because the APs are not installed properly, or because they're not using the right type of antenna. I've worked with troubleshooting with companies where they use omnidirectional antennas on high ceilings, and then RRM doesn't work, right? No kidding. RRM doesn't work because the APs can see each other with a very high transmit power. So the algorithm tune the power down, and then on the floor you end up having a very weak signal. I was saying, I've seen RRM work, right? And so if it doesn't work, it you might have a good reason why. There must be a reason why it doesn't work. So I try to ask questions. How are your AP placed? Which type of antenna are you using? Did you leave all the RM setting as default? All these type of questions that will try to help understand how the environment is set up. I always give the example of, it's kind of like the hallway example. It's just another perspective. If you have omnidirectional antennas under a high ceiling, and then all the APs will see each other very well. So RM was pretty much tuned down the power, but because you're in a high ceiling environment, like you won't get much signal on the floor, and then RM doesn't work, right? But RM doesn't work because you're not using the right equipment, right? The right type of antenna and so on. So try to find try to understand why it doesn't work, and then in some situation you will be able to fix it. In some other situation, they had to use static to fix issues. And static is definitely, like the easy fix for us, I guess. You can just, especially if you're just working on a specific troubleshooting case, this floor doesn't work, this office doesn't work. It's easy to create a static plan and implement it and then see the results right away. But if you can spend some time to troubleshoot the customer and they're really interested in keep using RRM, you can try to, evaluate their environment and see how you can help them. That's kind of like how I see it.
Yeah, and I agree. I say what you just said is exactly what I would say. And I would go as far also to add that RRM is really a tool that we could use to create a little bit more efficiency with how we manage wireless networks. Now, it might not be very beneficial for you if you only have a handful of APs in your environment. Where I think it could help you out is if you have some sort of persistent interference in a specific area affecting an AP, and then it could adjust that, right? It could say, all right, I'm not going to be on channel 36. I will switch to channel 52, for example. And then that way the client's experience is much better and it has been mitigated faster. Where I really see RRM helping is an environment that has a lot of APs, maybe thousands of APs, hundreds of them, where you might have one person who needs to tend to wireless and maybe can't get to it fast enough. And I think RRM can help in that scenario as well. I think if it needs to make changes faster in the course of an event, then that's beneficial for us. And it's an extra tool that we could utilize in our day-to-day to help us resolve some issues and even tell us whether or not there are problems, right?
Yeah.
Even when it comes to deploying, if you're going to deploy a bunch of APs and you restart DCA, it can help you pick better channels after you've done an installation. So I think there's a lot of benefits to it, but it's not perfect, right? You have to still keep your eye on it and validate that it is working to your advantage. And if it isn't, then yeah, you could create some APs statically assigned with transmit power and the channels, and then RRM will work around that as well.
Yeah, so I think it's a tool that allows us to scale. It scales very well, right, with the environment as long as you design properly. And then I would encourage everyone to listen to the Cisco Champion episode because we gave more tips, more practical tips. Jim gave some command lines we could use to monitor RRM. If you want to use RRM at a deeper level, you're gonna have to get your hands dirty and use CLI on the controller, which is the good news, right?
Yep. Yeah, and I mean that's where you get a lot of detail. That's where you get into the very finite settings of RRM and of the controller itself. And I think that's a really big benefit to having a controller on premises versus having a cloud. But that's a different conversation.
Exactly. And now that we're all learning Python, we could use those Python skills to retrieve some RRM information from our controllers, I'm sure.
Yeah, there you go. Well, that is the end of our conversation about our basically our reaction to having this discussion with Jim Floric on Cisco Champions Radio. We will link out to those resources over at the show notes. If you guys just head over to cleartosend.net and you'll see the RRM episode there. We'll also link out to older RRM episodes that we've had. But if you guys want to chime in and provide your feedback, your experience with RRM, I think it'll create a great discussion. So if you leave your comments or even have a conversation with us on Twitter, that will be awesome. So that's all we have for this episode on RRM. We hope to communicate with you guys further, and we will see you guys on the next episode.
Thank you, guys.
Thanks, guys.